Hello EAP Math, this is Mr. Chen. Let's go and take some notes on graphing angles in standard position. So, let's read it. Idea. You measure angles in degrees. You can graph these angles in a coordinate plane. Think of the angles as a rotation in a circular way. To be more specific, you are circulating in a counterclock direction. So when I count counterclockwise, meaning from right to left, it's going to be positive. And when it's clockwise, from left to right, that's going to be a negative degree. So we always start at the first quadrant right here on the x-axis. Right here, this will be 0 degrees. And if I rotate this direction upwards towards the middle, from here to here, I'm sure you can see that it makes a right angle. So this one right here is 90 degrees. As we continue over here, that's going to be 180. And you can see it's half a circle. A whole circle is 360 degrees, so half of it would be 180. And once again, from here to there, we're going to add 90 degrees. So 180 plus 90, that'll give me 270 down here. And we'll return to the original position after making a full circle, and we know that's 360 degrees. Let's go the other direction now. So if we're going clockwise from this direction, from the beginning, we're going downwards first. That's going to be negative 90 degrees there. That's going to be negative 180, negative 270 degrees, and of course, negative 360 degrees. Remember, we can keep going in circles forever, right? So if we're going this way, like if we keep going after negative 360, we'll get negative 450, negative 540, negative 630, negative 720, right? You just keep going increments of 90 as you go around. All right, let's go ahead and move downwards here. So if we were graphing 20 degrees, you know, what quadrant is going to be in? Well, it's going to be between 0 and 90 degrees, so it's 20 degrees. So you know that approximately, it might be about right there, right? This right there would be your 20 degrees. Let's take a look at 210, right? Feel free to pause this video at any time to try yourself before you check my answers. 210. So 210 is going to be between 180 and 270. So that's going to be in the third quadrant right here, right? So we know that this is going to be in quadrant 3. 1, 2, 3. And the angle will be from 0 all the way to somewhere about right there. So this is 210 degrees. Let's go back for a second to the first one. So that's first quadrant, because in the first quadrant. Now let's look at negative 100 degrees. Where would that be? So if it's negative, I know I got to go in the clockwise direction. So 0 to 90. Right, negative 90 right there. I got to go a little more. So it's right here, a little bit more. So from 0 degrees to a little past negative 90, about right there. That's going to be negative 100 and degrees, and that's also in quadrant number 3. Let's continue moving downwards here. 45 and negative 315. Let's try yourself first. Go ahead and try yourself. Let's see, so 45 degrees between 0 and 90. First quadrant. Aquí. 45 degrees. And notice it's going to be right in the middle, right? Because between 0 and 45, about right in the middle. Next one, we have negative 315 degrees. So 0, negative 90, clockwise direction. Negative 180, negative 270, negative 360. And it's also negative 360. So I'm all the way back in quadrant 1. From here, I'm going to go all around negative 90, negative 180, negative 70, negative 315. So about right there. That's going to be a negative 315 degrees. All right, let's see. Yeah, so right now, let's do your direction first. Use the graph to draw each angle in standard position. Identify a negative version of each angle. Label each angle appropriately. Go ahead and pause the video and see if you can figure that out. Now, let's see, negative. So I'm going to draw each angle first. So I have 240. 240 is going to be counterclockwise is positive. So 0, 90, 180. A little bit more, probably about right there. Not quite 270, right? Because it's going to be 240. And we know that right here is 270 degrees. So I'm not going to go, I'm still in the third quadrant. Well, the negative version of that, oh, that means I have to go from here to there. I have to go from here to there. Well, what's the negative version of that? So essentially, you can think about it in terms of, well, how far from 240 to get to right there, 360? How far is 240 from 360? Well, I can kind of do a simple math here. So 360 minus 240, that'll give me 120. So the negative version of it, I'm going to put it in red, is negative 120 degrees. From here, 0 to 90, and a little bit more, 30 more to get to 240, negative 120. So that's kind of a negative version. You can think about it in terms of, you want to write this down, how far away from 360 is a negative version. So let's try the next one. Let's try the next one here. So next one, we have 30 degrees. So 30 we know is in quadrant 1, about right there. The negative version, I have to go pretty far. So starting from here, 0 degrees, I got to go negative 90, negative 180, negative 270, and I got to go another 6 degrees, so negative 330. You might be like, wait, how'd you get 330? Well, if we take 360 minus 30, we get 330. That is how far it was to go all around to make that circle to meet the 30 degrees again. So the negative version of 30 degrees is negative 330. Let's try the next one. So 135, I know that's going to be in the counterclockwise direction since it's positive, 90, and a little bit more, about right there. Not quite 180, not quite halfway, so 135 degrees. Let's do some math here. 360 minus 135, 225. So I know that my negative degree is going to be 225. Let's check. Negative 90, negative 180, and that makes sense. A little bit more. 225 after negative 180. So negative 225 is my negative version. Degrees. Sorry about that. Yeah, I mean, go ahead and pause if you want to try 4 and 5 by yourself before you check in with me. So, number 4, 270. In the positive direction, it's all 90, 180, 270, right there. And I'm like, okay, the negative version has to be from here to there. And I know that's a 90-degree angle. So then I know the negative version is simply negative 90 degrees. And I can see that I've added the absolute value of 270 plus 90. 270 plus 90 is 360. So negative version here is negative 90. Last one for this part, 300 degrees. So 90, 180, 270, poquito más right here. So that's going to be 300 degrees. The negative version, well, I'm going to do some mental math now. I'm not writing it out on purpose. How far from 300 to make 360? 60 degrees. So I know the negative version here is going to be 6 degrees, negative 60. All right, let's keep going here. Next part. Use the graph to draw each angle in standard position. We'll draw it again. Identify the positive version of each angle and label each angle appropriately. All right. Once again, I feel like you can pause and try yourself before you watch me do it. So, negative 210, negative 90, negative 180, negative 210. How far from 210 from 360? So that should be 150. So that's 360 minus 210. You get 150. So right here, 90 and a little bit more. So that's why it's 150. Two together, the 2 adds up to 360. Next one here, we have negative 180, negative 90, negative 180. And I'm not going to, you should know, it's half. So the other half must also be 180 because 180 and 180 makes 360. So the positive version is 180. All right. Negative 330, 90, 180, negative 270, about right there. So that's negative 330. How far is that from 360? Just 30. Just 30 degrees. So the positive version is 30 degrees. Negative 30. Ooh, let's go down just a tad. Right there. Negative 30. Positive version, we're going to go all around. 90, 180, 270. And it should be 330. 330 and negative 30. Opposite value, add together, it's 360. So here we got 330. Oh, sorry. The one above should be only just 30. Let me erase that. Apologies. I'll just cross it out. Just 30 above. Last one here. Negative 135. Negative 90. A little bit more right there. Negative 135. We've done something like that before just above. If you take a look right there. Right here. So we know that the other side should be 225. Because 225 plus 135 is 360. So, positive version from here to there, 225. Okay, chicos. So, we will now talk about converting between radians and degrees. Before that, though, we gotta know what is a radian. Well, a radian is the angle made by taking the radius and wrapping along the edge of the circle. Let me show you what that looks like. So, let's say I have my center of the circle. Radius is from center to the edge, so this is a radius. And what we're going to do is we're going to take that same radius and wrap it around that edge of the circle. Just like that. Remember, so it's R here, length is R right there, and we're going to create another radian right there. Like that. Now the radian is this degree that's created, made by when we wrap the radius along the edge of the circle. This degree, you don't really know this, but just for your reference, is about, this theta is about 57.2958 degrees. Well, why is that significant? Now, if we continue to do this process, so let's say we continue to wrap the radius around over and over again. So we have, you see us 3 times, so almost at half the circle, and we'll wrap it a little bit more. That'll create half the circle. Because what happened is when we get 3.1416 radians, that's equal to pi radians. 1/6. That's pi radians. And another question is, well, how many degrees is half a circle? We talked about this earlier. Whole circle is 360, so half of it's 180. So another way to think about this gives us the conversion factor that pi radians is also equal to 180 degrees. Once again, this is the key takeaway. Pi radians is 180 degrees. So whenever you are converting or going back and forth, which is the goal of today, our goal of this lesson, once again, is to convert between radians and degrees. Go back and forth, right? So if we're converting, we're going to use a conversion factor of pi is equal to 180 degrees. Now let's go ahead and go to the next page and see what that looks like. All right, let's do some conversion here. So if we're converting degrees to radians, we have to now use the conversion factor of the fact that pi equals 180 degrees. Just like chemistry, when you were doing conversion between units, or even in engineering, when you're converting between units, we have to get rid of the certain unit, in this case degrees, and get a new unit, which in case it's pi. So what we're going to do when we convert from degrees to radians is we're going to multiply by pi over 180 degrees. You might be asking, well, why do we do that? Well, let's take a look. 240 degrees times pi over 180 degrees. Just like before, for example, if you had miles and miles, numerator, denominator, inches, inches, kilometer, kilometer, seconds, seconds, those units cancel out. So by putting degrees in the denominator, it will effectively cancel the degrees out for us, just like that. So now we're left with 240 times pi over 180. I'm doing some canceling here. Divide both by 10, so 24 becomes 240 becomes 24, 180 becomes 118. I can now cancel some more. Both numbers can be divided by 3. So 24 divided by 3 becomes 8. 18 divided by 3 becomes 6. I can divide some more. 8 divided by 8, they can be both divided by 2. 8 divided by 2 becomes 4. 6 divided by 2 becomes 3. So my final answer is 4 pi all over 3. So in a sense, 240 degrees is equal to 4 pi over 3 in radians. Degrees, radians. Radians always has pi in it. Maybe you want to tell yourself that. Maybe you want to write it down. Radians always has pi in it. All right, let's convert another one. So let's convert 120 degrees, negative 120 degrees. We're trying to get rid of the degrees and become radians, which is pi. So we gotta put the 180 where? In a denominator. This way helps out cancel out the degrees. Let's go and do some simplification. That cancels out. Divide both by 10 because they both end in 0. Becomes negative 12 over 18. It can be both divided by 6. So negative 12 becomes negative 2. 18 becomes 3. My answer becomes negative 2 pi all over 3. And we know that negative 120 is equal to negative 2/3, negative 2 pi over 3. So now let's go ahead and now look at how to convert from radians to degrees. So you know that when you deal with degrees, there is no pi. So now in radian form, it has a pi. So how to get rid of that pi in the numerator? We need to put in the pi in the denominator when we multiply. So the conversion factor from radian to degree is, write this down, it's 180 over pi. And let's see what happens here. So I have 7 pi over 6. I want to change this into degrees without the pi. So I'm going to multiply it by our conversion factor, 180 over pi. Let's go ahead and do some simplification, canceling. Pi divided by pi becomes 1. Goes away. That's our goal, because we only want degrees at the very end. Now, I got to do some more simplification here. 180 and 6, they're both divisible by 6. So let's divide both by 6 here. 180 becomes 30. 6 by 6 becomes 1. And now it's very simple. All I have is 7 and 30 in the top, 1 and 1 on the bottom. So my answer is 7 times 30, 210. So 7 pi over 6 is the same thing as 210 degrees. Last example for the day here. So we have 5 pi over 4. Change degrees here, our goal, degrees. So I need to get rid of the pi. So I got divide by pi here, multiply by 180. That's that cancel. Pi divided by pi becomes 1. 180 and 4, that can be both divided by, maybe some of you will say 2. Let's do 2 first. So then 2 and 2 becomes 4, it becomes 2, 180 becomes 90. You should be like, oh, I can divide by 2 again. 2 becomes 1, 90 becomes 45. So now all I have left is 5 times 45. 45 times 5 here, 225. So 5 pi over 4 radian become 225 degrees.